Hey there, your mates. In this video, we're going to be going through exercise 6F, which to me, for a lot of students, they may not get to this point, but it is helpful to then understand how you can apply rates to solve your problems. So let's have a look at a few rate problems here, typical ones. So example one's an easy one to start off with. Joanne can type 80 words per minute. So every minute, Joanne can type 80 words. So the question is, how many words can she type in 25 minutes? So the nice thing is that when you write it out, it's 80 words per minute, right? So per 1 minute. But then they're asking, well, what if it was 25 minutes? Okay, how many words would there be? Well, the logic to this is that, well, from 1 to get to 25, I would have to multiply by 25. True? But whatever you do to one side of the rate, you have to do the same on the other side. So here, I actually don't know what that multiplication is. Let's use a calculator. 25 times 80, that gives you 2,000. So that tells me now that 2,000 words will be typed in 25 minutes because we're just using that rate, that if every single minute, assuming that Joanne doesn't make a mistake and it's always the same for every minute, then it's 80 words per minute all the time. But then after 25 minutes, she should be able to type 2,000 words. So then your answer here is then say, how many words can she type? She would type 2,000 words. All right, pretty straightforward for example 1. Let's have a look at the second one now. Example 2 says a hot dog vendor sells on average 60 hot dogs every 20 minutes. Okay, so that must be the rate. So there are two quantities there. So 60 hot dogs per 20 minutes. Okay, how long is it likely to take to sell 210 hot dogs? So 210 hot dogs, how many minutes would that be? All right. Now, you can see that 60 doesn't fit nicely into 210, so it makes it a bit harder to sort of figure out, because had I said 120 hot dogs, I'm pretty sure most of you would have intuitively told me it would have been 40 minutes, right? But the question specifically wants you to see, well, how would you solve it if it doesn't fit nicely? So here's one of the other techniques. You can simplify the rate, okay? Simplify the rate so that you can then work out for 210 hot dogs. So if you think about it, if you can work out how long it takes for one hot dog, so I'm going to do it in another color. If you can work out for one hot dog, right? So for every one hot dog, how many minutes will it take? Well, then you can go from 1 to 210. See what I'm doing there? So thinking about it logically, how do I go from 60 to 1? Well, instead of multiplying, I'm going to divide by 60. 60 divided by 60 will give you one hot dog. But that also means that the rate, whatever you do to one side, you have to do the same for the other on the rates, right? So I'm going to divide it by 60 as well. Now, what's 20 divided by 60? Well, 20 divided by 60 is actually, let's go 20 divided by 60 simplifies down to 2 over 6, which is 1/3. So it's actually 1/3 of a minute. Okay, so that means that one hot dog is sold every 1/3 of a minute. Now you can work out 1/3 of a minute. That's just what 1/3 times 60. What's that? 1 divided by 3. So it's 0.33 minutes. Okay, or you can times that by 60, and essentially it's 20 seconds. Okay, so 1/3 of a minute is 20 seconds. So every 20 seconds, you are selling one hot dog. So one hot dog per minute is 1/3 per 1/3 minutes. But what you're trying to figure out is, well, what if you had 210 hot dogs? How long will it take in terms of minutes? Well, since you know what 1 is, so 1 to get to 210, we know we have to multiply by 210. So it's like here, I need to multiply that by 210. So that means on the right-hand side, I need to multiply that by 210 as well. So if I took 1/3 and I said multiply by 210, okay, and you can do that on a calculator, you can do it by hand, it's up to you. So 1/3 times 210. Hopefully you can see that you can simplify this. 3 goes into 3 once, and then 3 goes in 210 70 times. Or you can type it all in your calculator and you would have got 70. So the answer is for 210 hot dogs, it would actually take 70 minutes. And all you had to do there was calculate what 1/3 times 210 equals to. Okay, so that one was a bit trickier than the first example, but that gets you to understand that you can use the initial rate, simplify it so that it can help you solve the problems that you want to do, right? Now, example 3 is the last one, and this one is a nice one, a common, typical one that students tend to have troubles with. But let's try this one here. Let's have a look at this one. Example 3 says you've got 2 hoses that are used to fill a large pool. Now, the first hose alone, just by itself, it takes 100 hours to fill up one pool. So it means the rate is that it's for every 100 hours, it will fill a pool for hose 1. Whereas the second hose takes 150 hours to fill up one pool. Now, the reason why you can't combine them together is because they're running at different rates. So you can't just add them and say, oh, yeah, that's how long will it take if you combine the 2 hoses together to fill up a pool? You can't say, well, 100 plus 150 is 250 hours, and then you get 2 pools per 2 pools. That's not true. Okay, they're running at different speeds, so you can't combine them. It's like adding fractions. You can't combine half of a pizza plus 1/3 of a pizza because they're not the same types. You see, so half a pizza would look something like this. This is half of a pizza, okay? Whereas a 1/3 of a pizza could look something like this. How can you add those two together? It's like one is half and then one is 1/3. They're not the same quantities, yeah? So what we do is then we look at a pattern. So if for one pool, hose 1 can do it in 100 hours, that means for 2 pools, it will take 200 hours. Then 3 pools would be 300 hours, and then 400 hours, and then 500 hours, and so forth, right? So that's the pattern for hose 1. Hose number 2, to fill up one pool, it takes 150 hours. And then for 2 pools, it takes 300 hours. And then for 3 pools, it takes 450, and then 600, and then 750, and so forth, right? Now, where do they both share some sort of similar quantity or rate? Well, you can see here they both have the same 300 hours. Okay, so we can see that at 300 hours, okay, in the same common time, together, we know that hose number 1 will fill 3 pools, whilst hose number 2 will fill 2 pools. So that means in 300 hours together, they would have filled 5 pools. Okay, so rate together for both hose 1 and hose 2 is 5 pools per 300 hours, because that's the common speed. That's the common time that they will tend to meet. Okay, so it's very likely the next one, if this was 6 pools, this would have been 600 hours for hose 1. And can you see 600 and 600 again? So it seems like for every 300 hours, they're going to have a common amount that we can work with. So together, both hoses fill out 5 pools per 300 hours. So if you want to work out the rate, well, the rate is usually in terms of per hour, so per 1 hour. So how do you go from 300 down to 1? Well, we would have had to divide it by 300. But whatever you do to one side of the rate, you have to do the same for the other side of the rate as well. So that means how much of a pool will be filled? Well, it will be 5 divided by 300, which that means, what's 5 divided by 300? 5 divided by 300 is 0.016. Or if you leave it as a fraction, we can say that the answer is, what's that? 1/60. So 1/60th of a pool will be filled per hour. Okay, so for every hour these 2 hoses turned on together will fill 1/60th of a pool. Okay, and that's about 0.016666 of a pool. And that's the answer. That's the idea. Okay, so that's how much the rate would be, and then that's all they wanted you to do. So how long would it take to fill the pool if both the hoses were... Oh, sorry, no, I haven't answered the question. So the question was asking, how long would it take to fill the pool? So you need one pool. Whoops, my bad. I should go back to this then. We're actually trying to figure out how long it takes to fill up one pool. So let's do it again. So to fill up one pool, we need one pool, don't we? So we need to know, well, how long will this take in terms of hours? Well, logically, 5 pools down to one pool, I need to divide it by 5. And then this one here, well, whatever you do to one side, you got to do to the other. So if 300 divided by 5 will tell me it takes 6 hours. So therefore, 6 hours to fill up one pool when you turn on both hose 1 and 2 together. Sorry, that was my mistake there, but hopefully this now makes sense to you, and I'll stop the video there. But this is a very common problem to practice. I recommend you doing the problem solving if you're up to this. Okay, so if you're up to this part of the exercise, well done. You are probably ahead with than many other students. Okay.